All right, so looking back to that, to those GIFs of the crash test dummies, where we had a windshield that was 0.03 meters thick and an airbag that was 0.3 meters thick. Let's use this information to try to figure out the kinetic energy. Kinetic energy equals 1/2 mv squared. We have a stopping force. Let's first get the kinetic energy, right? A equals 1/2 mv squared. If the mass is 70 kilograms, it's going to be half of 70, which is 35, times velocity squared, 13 squared. So this equals to 35 times 169. And when I do that, I get a kinetic energy of 5,915 joules of energy. Okay, what about this stopping force if we have a windshield that is 0.03 meters thick? We know that work equals the change in kinetic energy, and that delta means final minus initial, right? So ending minus starting. What is our ending kinetic energy? Well, if we're stopped, then our ending kinetic energy is 0, minus the starting, which is 5,915. All right, so I just had to clean that up. So what we have found so far is our work equals negative 5,915, and that work equals our change in kinetic energy at the same time. Well, it also equals force times displacement. So all of this is still equal. So I'm going to bring down the useful parts, the negative 5,915 joules, and set that equal to force times displacement. I will divide out displacement, and I'll plug in my two numbers. When I do that, I'll solve for my two forces. So force 1 is when we have the 0.03 meters. So it's 5,915 divided by 0.03, and that's going to give me 197,166 newtons of force. That's my first force. When I look at it with the airbag, which is 10 times more stopping distance, then I'm going to get 19716, 19,000 newtons. A huge difference just by increasing from 0.03 meters to 0.3 meters. So by adding in that extra stopping distance, we have decreased that force tremendously. Let's try another one. Try this for yourself. Pause it, see if you can do it on your own, and then press play to see if you got the right answer. A total of 12,000 joules of work is required to stop a 45 kilogram cart. So we have 45 kilograms cart, we have 12,000 joules of work. What speed would the cart be traveling before it was brought to a stop? Well, we have our three equations. Which speed? So kinetic energy has speed in it. We're given mass, okay, but we don't know how much kinetic energy. What we do know is 12,000 joules of work. Okay, we don't know what force is. We don't have any idea of the stopping distance. Work equals the change in kinetic energy. So we will use this equation, this work equals change in kinetic energy. If work equals 12,000 joules, and that equals our change in kinetic energy. That means our ending kinetic energy minus our starting kinetic energy. Our ending kinetic energy is going to be 0 because we come to a stop. So that means there's a negative amount of work that is done because we are coming to a stop. So our final kinetic energy is 0 minus our initial kinetic energy. Now we'll solve for initial kinetic energy. I'm going to add KE to each side, so that way it just makes it positive. and then I'm going to add 12,000 to each side, so that way that makes it positive. So we get KE equals 12,000 joules. Great! But that's not what the question's asking for. The question's asking for the speed, and we know that kinetic energy equals 1/2 mv squared. So I can use my equation here. All of that equals to 12,000 joules. And now I can solve for my velocity. To solve for my velocity, I'm going to multiply by 2 on each side to get rid of that fraction. Multiply by 2 here, and I'll divide by my m, which is 45 joules on each side. And when I do that, I get v squared equals about 533 meters per second. But that's not what the question's asking us for, because remember, we're still in squared. So we have to take the square root of each side to get our final speed. Velocity equals about 23 meters per second. So that's pretty cool, I think. We were given some amount of work that was done. Work is the transfer of energy into a system or out of a system. And we found out that it stopped, and we knew the mass of the car. Just from that information, we were able to figure out how fast the car was going before it came to a stop. The next part, pause and try for yourself. Okay, so we have the cart stopped in a distance of 3 meters. What force was needed to stop the cart? What force? So we're definitely going to have to use this, and we're given the distance. Great. Do we know the work? Hey, we do know the work. So this is just going to be a nice easy one. Work equals F, what is happening here, times D. And we're solving for F. So you can plug in your numbers here. 12,000. I don't know what's happening to this thing. I'm sorry. Okay, I rewrote it over here. Sorry. 12,000 equals force times 3 meters. So now when I divide 3 meters from each side, I will get the amount of force measured in newtons required. So 12,000 divided by 3 is going to be 4,000 newtons. So our force equals 4,000 newtons.